Let us begin our study to know the actual structures of these ionic crystals, especially cubic ionic crystals. I already told you there are six types of cubic ionic crystals. Number one, rock salt. Number two, cesium chloride. Number three, fluoride. Number four, antifluoride. Number five, sphalerite. Of course, it is zinc blende. Number six, perovskite structure. Let us study today cesium chloride structure. It is a one of the type of the structures. We are applying radius ratio rule to explain the structure. Before to actual explanation of the structure, let us know what is that radius ratio rule. Radius ratio means ratio of radius of cation to radius of anion. If that ratio is less than 0.155, type of void, type of gap, type of hole will be linear. Coordination number will be 2. If it is between 0.155 to 0.225, type of void will be triangular planar and coordination number 3. If it is between 0.225 to 0.414, the type of void will be tetrahedral and coordination number 4. If type of void is octahedral, then radius ratio should be 0.414 to 0.732 and coordination number 6. If void is cubic, then coordination number will be 8 and radius ratio will range between 0.732 to 1. Here what we will do, we will get the data for size of cation and anion, means radii of cation and anion, and we will find the ratio of them, where that ratio stands. Accordingly, we will get idea about the void. We will get idea about coordination number. So we will be with rough picture about the ionic compound. Then we will go to actual structure that experimentally we found. And rationale behind that will be clear to you. So radius ratio, its application, its importance and understanding of our structure, all things will be fulfilled. Now let us apply radius ratio rule for this example. Cesium chloride. Sizes of cation and anion can vary from book to book, but most acceptable values that I am considering. Radius of cesium plus ion is 169 picometer and that of chloride ion is 181 picometer. So as per our definition of radius ratio, what will be the radius ratio? It is a ratio of 169 picometer to 181 picometer. What is answer? 0.934. What does it signifies? It says that whatever the gap, whatever the hole, whatever the void formed by anions, chloride ions, is of the type cubic. Means to that void around the gap in which cesium ion will be there, how many chlorides will be there? 8 chlorides will be there. and that is a fabulous idea given by radius ratio rule. One of the important application of radius ratio rule. These are our theoretical calculations. But let us see how actually the structure of cesium chloride is. Whatever we found theoretically by the application of radius ratio rule, is it valid? Let us see. Here is a structure of cesium chloride. As per our prediction from radius ratio rule, we are finding cesium ion is at center of the cube and chloride ions are at corner of the cube. See here, by green color chloride ions are represented and by yellow color cesium is represented. What was the type of void or type of hole as per radius ratio prediction? It was cubic void. Yes. For primitive cubic or simple cubic arrangement of the chloride ion, there is a gap at center of the cube and the type of gap is a cubic gap and that is occupied by cesium plus ion. Can you count number of nearest chloride ions surrounding cesium plus ion? Yes, they are 8. So what is the coordination number of cesium plus ion? 8. What about chloride ions? How many cesium ions can surround one chloride ion? If you imagine the continuation of the structure, continuation of these cubes, then I told you already a corner has a share by 8 total number of cubes. Means to one corner 8 cubes can surround. It means one corner is shared among 8 cubes. It means the ion at corner, chloride ion will be shared by 8 cubes. And as per this structure, at the center of cube, who is there? Cesium ion is there. So what will the meaning of our arrangement? The chloride ion will be surrounded by 8 number of cesium plus ion. So what is the coordination number for chloride ion? It will be 8. So what is the coordination number representation? 8 is to 8. It's the way of presentation. First we represent the coordination number of the cation and then we represent the coordination number of the anion. Are you getting this coordination number concept? Now let us find stoichiometry. Stoichiometry means proportion of the cation and anion in this structure. It is a representation of the structure. It is a unit cell of the structure. So in actual crystal lattice, the replication or repetition of this unit cell will be there. Now tell me, in this unit cell, how many cesium ions you find in total, complete cesium ions? Actually, there is only one cesium ion and that is completely belonging to the cube. It is at the center of the cube. Therefore, its contribution to this cube, its contribution to the unit cell will be 1. Means if I have to say how many complete cesium ions are there in this represented structure, 1 cesium ion is there. Let us calculate number of chloride ions. How are chloride ions arranged? Chloride ions are at corner of the cube and chloride ion which is at the corner can have shared to the cube how much? 1/8 or 1/8. How many such chloride ions are there? 8. So total number of chloride ions in this unit cell will be 1/8 into 8 is equal to 1. Means number of cesium ions is equal to 1. Number of chloride ions is equal to 1. So what should be the formula? CSCl. So whatever the formula we represented, that is validated here. Stoichiometry is verified here and our structure reveals that stoichiometry. Are you getting? So stoichiometry means ratio of cation to anion in number 1 is to 1. So I represented that stoichiometry is 1 is to 1. Let us learn to draw this cesium chloride structure. It is somewhat simple, but I inform to you. First draw such a square. Then draw similar sized one more square in front of that previous square. Means now new square is towards us. Now join respective corners by parallel lines to form such a beautiful cube. Now I should arrange this one cesium plus ion shown by yellow color and 8 chloride ions here are shown by green color. Where should I place that cesium plus ion? Yes, at the center of the cube. Here it is at the center of the cube. What about chloride ions? Where should I place them? Right, I should place them at each corner of the cube. Here are chlorides at each corner. Yes, this is the structure of cesium chloride. Is it not easy? These are the other two examples which show similar structure as like cesium chloride. One is calcium sulfide and other is cesium cyanide. Now homework for you. The first question is you have to find radius ratio for zinc sulfide and you have to predict the type of void or type of gap present for zinc ions due to sulfide ions. And second question is I had given you other examples of cesium chloride category structure. So out of those two, for any one example, you have to show calculations for radius ratio and you have to represent those calculations in comment box. Are you getting these two questions? I am waiting for your answers. Let us discuss the structure of zinc sulfide cubic category in next part.